Use the graph of y equals sine theta below to sketch the graph of y equals cosecant theta. We know from previous experience that these two are reciprocal functions of one another. For example, if sine is 1/2, then cosecant is 2 over 1 or 2. The reciprocal property also um, helps us to graph. We take the graph of sine, which is, I did in light gray. We have the series of hills and valleys oscillating over and over. There are places where your sine value is 0. We're going to pay attention to those locations. Those are the x-intercepts of sine. And we're also going to use the max and min values of sine, which are 1 and -1, respectively. Now, when you take the reciprocal, if you go to the peak or the maximum value of sine and you have 1, the reciprocal of 1 is still 1. So that's why those graphs would touch each other at the maximum value of 1. -1, its reciprocal is also -1. 1 over -1, that's still -1. So your hills and valleys are common points between the two functions. Where you run into a little bit of trouble is, for example, at half, if you pick an angle where sine is equal to half, and we know that's at 30 degrees or pi over 6 radians, 1/2, its reciprocal is 2. So that's why the graph was up here at 2 instead of 1/2. The x-intercepts of sine occur at integer multiples of pi. -2, -1, 0 pi, 1 pi, and 2 pi. When you take the reciprocal of 0, you get 1 over 0, which is undefined. These red dashed lines are called vertical asymptotes. These occur at all integer multiples of pi. Those are invisible boundaries that your graph will not cross because they're undefined at those particular angles. So cosecant, basically what you do is you take the graph of sine, you build in your vertical asymptotes at all the integer multiples of pi, you take the hilltop of sine, and then you go the other way, you reciprocate. All these values less than 1, once you take the reciprocal, they're going to be larger. Take any fraction like 1/3, 1/4. When you take its reciprocal, you'll get 3 and 4. Those are much larger. Those are way up here. This series of red hills and valleys make up the graph of cosecant theta, including the vertical asymptotes. What you would do is, to see the true graph of cosecant, is you would take away this gray sine graph and you would take away the red dashed lines. Just the sequence of red hills and valleys, that's the graph of cosecant. Similarly, if we take the graph of cosine, and that is again in light gray, this is the graph of cosine, 2 cycles worth. The maximum value of cosine is 1. The minimum value of cosine is -1. So if you look at where cosine is 0, those are half and odd multiples of pi over 2. So you would have like -3 pi over 2, -1 pi over 2, +1 pi over 2, +3 pi over 2. It's all the odd multiples of pi over 2. Everywhere cosine is 0, secant will be undefined. So these blue vertical asymptotes are in here at the odd multiples of pi over 2 to help locate where the invisible boundary occurs for your graph of secant. This blue graph, and like we discussed above, on cosine, if you take a value less than 1, like a half, and you take the reciprocal of 1/2, you get a 2. So secant runs the other way from hilltops and valley floors of your cosine graph. This series of hills and valleys that are in the blue ink are your secant, is the secant theta graph. Now, because asymptotes have come into play, and we've also discussed amplitude, we're going to also begin looking at domain and range. Specifically, let's start with sine and cosine. Sine is the graph in red. Cosine is the graph in green. Both of these graphs oscillate over and over, up and down forever. In fact, there is no angle you can't take the sine or cosine of. Try it with your calculator. Press your sine button or cosine button. Just randomly make up some number, positive or negative or zero. When you hit enter, you're going to get some kind of an answer. Now, due to the max and min values, the amplitude of sine and cosine, when you do hit enter, your answer will never escape the range of -1 to +1. The domain is all the values or angles that you can take the sine or cosine of, which is all of them. But the answers you get will never escape -1 to 1. You can get values between -1 and 1, and you can even get -1 and +1. But when you press enter on your calculator, you will never get an answer that's less than -1 or greater than +1. Infinite domain, restricted range. The range will coincide with the amplitude of sine and cosine. Let's discuss the range and domain for cosecant. Now let's also go back, let's think from the first slide. Cosecant is the sine curve, and if you'll watch this red pointer, I'm going to invisibly sketch the graph of sine. Hills and valleys, hills and valleys. You just don't have to do it all the time. While you're first learning, it's a good idea to lightly sketch sine. Cosecant is this series of purple hills and valleys. Now, because sine is equal to 0 at the integer multiples of pi, when you take the reciprocal of 0, you get undefined. So cosecant is undefined at all these vertical asymptotes. So how, instead of making a list, how can we write any angle except those specific ones? It turns out that your domain is any angle. It's easier to write what you can't have sometimes. That angle cannot be an integer multiple of pi. And I'm going to write this in a little bit under here. N is an integer. So any positive or negative whole number you can think of, that's an integer. Now, all the angles where you can produce a y value, those angles are good. It's just there's select angles that you can't use because the function's undefined. So your domain is any angle as long as that angle is not an integer multiple of pi. If you want to test it out, do 1 divided by sine of negative pi in your calculator. Make sure you're in radian mode if you're typing in an angle that's radians. But if you do 1 over sine of any of these integer multiples of pi, when you hit enter, your calculator is going to throw a fit because it's undefined. Now let's get to the range. The range is all the answers you get once you press enter, or all the values of y on a graph. Sine fluctuates up and down between negative and +1 forever. Due to the reciprocal, cosecant never sees the light of day between -1 and 1. So I put these light blue horizontal lines in here to help you see that cosecant never takes on any of these y values. The only y values this graph takes on are really negative until you get to -1. Those are for all the little hills, the ones at the bottom. The other interval is for all the little valleys. Those have a minimum value of -1, but they never peak. The property of an asymptote is you get really, really close without touching, but these get really large. So these two intervals together, -1 or smaller, +1 or larger, that makes up the range of cosecant. For secant, remember we can take the graph of cosine, which is a series of valleys, and then take the reciprocal of those. I left it out because it's just more clutter. Cosine was equal to 0 at the odd multiples of pi over 2. Odd multiples of pi over 2. So like -3, -1, +1, +3. Any odd number, multiple of pi, is a no-no. Secant will be undefined. So that's the reason for the vertical asymptotes. These series of hills and valleys that represent the secant graph are not defined for odd multiples of pi over 2. Now, in order to write that, we know pi over 2's got to be in here. So any angle, as long as that angle is not, this can represent odds. If you pick any number and double it and then add 1, your answer will be odd. So this is the notation for odd multiple of pi over 2. The range is the same for secant as it was cosecant. The graph never sees light of day, never has a function value between negative and +1. However, it does exist -infinity to -1, all these little hills. That's this first interval. Any value 1 or larger can be found on the series of valleys, and that's this interval. So your range is -infinity to -1 or 1 to infinity. Here's a little summary. The period of all 4 functions below, which are sine, cosine, secant, and cosecant, is 2 pi. The domain for sine and cosine is all real numbers, so any angle you can take the sine or cosine of. The range of sine and cosine is -1 to +1 inclusive. If you press sine or cosine of any angle, your answers have to be in here. The domain of cosecant was any angle as long as it wasn't a multiple of pi, specifically an integer multiple of pi, and that's any positive or negative whole number. The range of cosecant was the series of valleys and hills with the gap in the middle, so you go -infinity to -1, and then you've got that gap between the light blue lines in the graph above, and then the upper section is y values of 1 or larger. Same thing for secant on the range, but the domain's a little different. Cosine is equal to 0 at odd multiples of pi over 2, so secant is not defined at those locations. It is everywhere else, so it's easier to write. The domain of secant is any angle such that the angle is not an odd multiple of pi over 2. I hope this video helps. There's a lot of information in these 3 slides. Reach out by phone or email or ask in class if we're together, and I'll do my best to help you out.